students. In today's class we are going to have the problem Fourier transform. Already we done the same problem in the last class. So today also we are going to continue the same problem. Already we completed up to this. Okay, started with the Fourier transform formula. Then we replaced the function and also the limit. And we expanded the like this. And we split it into two integrals. And we verified which is odd and which is even. The function is odd, we can leave that down. If it is even, we can have 2 and starting from 0, which is considered same term. Okay, and use Bernoulli's formula, we are going to get the term which is like this. Okay. In today's class, we are going to continue after this. Okay. We just cancel root 2, root 2. So we can write square root of 2 by pi. And the first term is as it is, which is a square minus x square into sine sx by s. And just multiply those minuses. Okay, so which is minus 2x cos sx by s square, and the next thing is minus into minus is plus, so which is 2 into sin sx by s cube, and limit starting from 0 to a. Okay, the next thing is we are going to replace the limit. Okay, so before that we should know how to replace the limit. That is we already know, right? Basic thing is we just replace the upper limit. So which is square root of 2 by pi. Upper limit is what? A. Just replace x as a. Wherever you are having x, you just put the value as a. Okay. So the first term is what? A square minus a square. So which is 0. 0 into anything is 0. Okay. So first term is 0. And second term is 2. Just replace x as a and cos sa by s square. Second term is over. Go for the third term. Third term is 2 sin s a by s cube. So this is upper limit. Okay, and the next thing is what? Minus lower limit. Lower limit is what? 0. Replace x as 0 in the same terms. Okay, so which is sin, the value is 0. So 0 into anything is 0. So sin 0 is 0. 0 into anything is 0. And the second term is in front of this you have x. Replace x as 0. So 0 into anything is 0, and the third term is, which is also 0 because that term contains sign, right? So the whole lower limit is 0, then close the bracket. So that should be equal to square root of 2 by pi. Just read zeros. Okay, write the remaining term, which is 2a cos sa by s square and plus 2 sin sa by s cube. If anything is common, take outside. So 2 is common. So square root of 2 by pi. Take LCM as s cube. Already we have s square and s cube. Take the higher power. So which is s cube. That means auto multiply one s here. The numerator also auto multiply one this. So we say cos sa plus sin sa. Okay, so this way we want to find the Fourier transform. Okay, and want to compare this and the reduction. Okay, the reduction we just replace a as 1. Then we are going to get that down. Okay, that means a as 2 square root of 2 by 5 and replace a as 1. So the answer is s cos s minus sin s by s cube. Okay, so this way we need to find the Fourier transform. Okay, and the next thing is we are going to use inverse Fourier transform. Okay. Now we are going to have inverse Fourier transform. So this is the formula, and notation is small f of x equal to 1 by square root of 2 pi integral from minus infinity to infinity. Capital F of s e power minus isx then into ds. Okay, this is the formula. Now we need to bring this result. Okay, the result which is given with problem itself. Okay, so that should be equal to 1 by square root of 2 pi integral from minus infinity to infinity. This is we already done in the last class. So the answer is 2 square root of 2 by pi sinus minus s cos s by s cube. This is the answer that is we got in the last class. And we are going to expand the term, which is cos s6 minus I sin s6 then into ds. Okay, that should be equal to root 2 is cancelled and root pi is pi. Already we have 2 in numerator. You combine those two, which is root pi, integral from minus infinity to infinity, just multiply the term. Okay, so the term is sinus minus s cos s by s cube then into cos s6 minus I. Okay, write the same term, just from integral from minus infinity to infinity, sinus minus s cos s whole divided by s cube into sin s6 ds. Okay, and you will have a bracket, common bracket. Okay, that should be. So the remaining thing we are going to see